Good morning, everyone. My name is Nisha Kumari from BIT Sindri Dhanbad. My research topic on a Ball legal search optimization approach for congestion alleviation in power system transmission channel. First of all, what is congestion? Congestion occurs due to the lack of coordination between generation and load. Also, it occurs when transmission lines operates beyond its transfer limits such as voltage limit, stability limit, and heat limit. This occurs due to the outage of lines, overburden, inadequate reactive power failure, and weather diversity, and also sudden increment in load. It, to relieve the overburden in transmission network, congestion management is used while preserving the transfer limits. For congestion management, three conventional methods are generator rescheduling, load setting, and extension of new transmission line. From economic point of view, generator rescheduling method is mostly used for congestion management, which is based on the GSF values. GSF is generator sensitivity factor, which represent a change in real power flow in a transmission line K connected between bus I and bus J due to the change in power generation by generator G. Generators are selected on the basis of their non-uniform GSF values. Now comes to the problem formulation. Main objective of this paper is to minimize the rescheduling cost. For this, our objective function is to minimize summation of del of Cg into del Pg into del Pg, where del Pg is the real power at bus G and Cg are the incremental and decremental price bids submitted by the generators, which are subjected to different inequality and equality constraints. Pg minus Pg mean equal to Pg mean less than equal to del Pg less than equal to del Pg max is the inequality constraints, and summation of del Pg equal to 0 is the equality constraints, where Pg mean and Pg max are the minimum and maximum limits of power outputs. In methodology section, figure 1 represents the different steps for generator rescheduling method. At first, we consider a healthy standard power system network. Then congestion has been created with line outage. After that, run power flow to identify the congestion, and based on the congested line, GSF has been calculated. Then Bar-Digger search optimization algorithm has been applied to obtain the optimal values for power resettling. Then run power flow to see the congestion alleviation, and finally congestion alleviated. Bar-Digger search optimization technique is basically a newly developed meta-heuristic algorithm which mimics the hunting behavior of Bar-Diggers, and this algorithm is divided into three stages. First, select space, which is the initialization process. Second one is searching in space, which is the exploration phase, and third one is the swooping, which is the exploitation phase. In this paper, 39 bus stage system has been used, which has 10 generators and 29 load buses. Now comes to the result section. Table 1 represents the GSF for 39 bus system, in which GSFs are represented, and according to their sensitivity according to their values, non-uniform values, generator 1, 2, 3, 8, 9, 10 are selected for the generator rescheduling method, in which generator 1 represent for the slack bus, and which represent the losses in transmission lines. Table 2 represents the comparative evaluation with the proposed Bar-Digger search method for 39 bus New England system. Proposed methodology BES gives the result that rescheduling cost is $7944.28 per hour, and total cost is 502.10. Only 6 generators, generator 1, 2, 3, 8, 9, 10 participate in this generator rescheduling method, and this BES proposed methodology has been compared to the existing algorithms that are RED, PSO, ABC, and GSO. And after comparison analysis, we conclude that BS algorithm is most effective and gives the better result than the existing ones. And table 3 represent the system voltage and losses. Also, the proposed methodology bilegal search optimization technique improves the voltage stability, and also it reduces the losses, that is 57.96 megawatt. Figure 5 represent the congestion cost comparison with BS, and figure 6 represent the comparison of rescheduling power with BS, and figure 7 represent the voltage at buses post CM with BS, and the convergence curve is represented by figure 8. Now comes to the conclusion. It observed that generator number 2, 3, 8, 9 and 10 are sufficient to reschedule their power generation for congestion management problem, as they exhibit the non-uniform GSF values, and the congestion cost reduced by the application of Bar-Deagle search optimization, and this is $7,943.91 per hour. After comparing with other existing techniques, Bar-Deagle search optimization technique based solution gives the superior result, and improve the voltage profile, also reduce the dispatch cost. And future scope of this work is that can be extended considering the application of renewable energy sources into this framework and reduce the congestion cost based on the renewable energy sources. Also, modification in the optimization techniques can be done to achieve the better results. Now, these are the references which we have gone through this, and thank you everyone.